in and subset of. Suppose we have the set A, which consists of two elements, namely boy and cow. We can say that the element boy is in the set A. Similarly, we can say that the element cow is in the set A as well. We'll now introduce a symbol that stands for the English words is in. The symbol looks like this, like a curved E. So when we write it out as such, we say that the element boy is in the set A, and similarly, the element cow is in the set A as well. Now, of course, we can also combine these two statements into a single statement, namely the statement that the elements boy and cow are in the set A. The mathematical punctuation mark comma here stands for the English word and. Here's a true-false question. Suppose that as before, the set A consists of boy and cow, and now we introduce another set called B, which consists of boy, cow, and dog. Question, is the set A an element of the set B? 9, by the way, means no. A is not an element of the set B. Instead, we shall say that A is a subset of the set B. Just like we have a special symbol to stand for the English words is in, we also have a special symbol to stand for the English words subset of. It looks like this. Now for a more precise definition of subset of, given two sets S and T, we say that S is a subset of the set T if every element in S is also an element in T. Returning to our example of the sets A and B, we see that the set A is indeed a subset of the set B because each element in A is indeed an element of B. So boy is in B and also cow is in B. Hence, the set A is indeed a subset of the set B. So again, given any two sets S and T, we say that the set S is a subset of the set T if every element in S is also an element in T. Now, the definition which we just gave is actually entirely equivalent to the following definition. We say that the set S is a subset of the set T if any element that is not in T is also not in S either. So if we apply this alternative definition to the example we just gave, we see that A is indeed a subset of the set B because any element that is not in B is not in A either. Here's another true-false question. Using the same examples of A and B, is the set B a subset of the set A? Notice that A doesn't contain dog, so in order for B to be a subset of the set A, it must be the case that B doesn't contain dog either. However, this is plainly not true because B does indeed contain dog. Hence, B is not a subset of A. True, false. So again, we have the set A, and now we're also going to add the set C, which also consists of boy and cow. Question, is A a subset of C? Yes, absolutely. Every element of A is also an element of C, so of course A is a subset of C. So similarly, we can ask, is C a subset of A? Again, of course it is, because every element of C is also an element of A. Indeed, you've probably noticed that C is in fact the same set as A. And in general, it's going to turn out that if we are given any two sets, S and T, if S is the same set as T, then what we're going to have is that S is a subset of T, and also T is a subset of S. The converse is also true. If we are given any two sets S and T, if S is a subset of T and T is a subset of S, then the two sets must in fact be identical. We can combine the two claims just made by using this symbol here. This symbol stands for if and only if, or is equivalent to. So this statement that we have here can be read as follows. Two sets are subsets of each other if and only if they are in fact equal. Let's introduce one more idea. So again, we have the same sets A and B, and the set A is a subset of the set B. We can in fact also say that A is a proper subset of B. The symbol for proper subset of looks like this. Now for a precise definition, given any two sets A and B, we say that the set A is a proper subset of the set B if A is a subset of B and A is not equal to B. So looking again at our example, we see that A is indeed a proper subset of B because A is a subset of B, but A is not equal to B. Consider in contrast the sets A and C. We saw earlier that the set A is a subset of the set C. Now question, is the set A also a proper subset of C? Nope, it's not. A is equal to C, so A cannot possibly be a proper subset of C. True or false? If the set A is equal to the set B, then the set A is a subset of the set B. True. Here's another one. If the set A is a proper subset of the set B, then A is a subset of B. Also true. In general, A is a subset of B if and only if A is a proper subset of B or A is equal to B. One last thing to note, sometimes you see this horseshoe symbol here, and it's used to mean that S is a subset of the set T. Unfortunately, some writers treat this symbol as being synonymous to the subset of symbol that we used earlier, while some other writers treat it as being synonymous to the proper subset of symbol. So whenever you see this symbol, there's some ambiguity as to whether it means subset of or proper subset of. So my recommendation is to entirely avoid using this symbol altogether. Let's end this video with a couple of true or false questions. First, every set is a subset of itself. True. Well, every set is equal to itself, and so by what we learned earlier, it follows that every set is indeed a subset of itself. Here's another. Every set is an element of itself. Wrong. In fact, the exact opposite is true. No set is an element of itself. This is actually quite a subtle and tricky point, which we'll come back to in a later video. In the next video, we'll learn about why the empty set is a subset of every set. To go to the first video in this series, you can also click on the link on the bottom right.